So yeah, here we are. So like I was saying in the last episode, when I continue with this episode in the next one, I'll actually explain to you what would be required if we actually went to a planet and tried to build up like this here. Now obviously there's some things about this game that are just not close to even being a possibility, and there's other things which are pretty close to what we would actually try to do. And here they come. The first thing is we would be trying to harvest the resources from the planet. Small amounts with easy methods of access. I think in the last one I said about easy industrial fabrication with simple devices. It's 100% what we would try to do as humans, but it's not as easy as I made it sound. There's still some complexity even within what I'm talking about there. Tritium, uranium rod, and super alloy. Okay, so we will start with trying to extract resources. Now, unlike what this game does, where we just drill, rig, and mine resources in that way, if we went to another planet, what we're going to do to harvest is we are going to actually more than likely use electrode smelting as one of our methods for gathering, provided the atmosphere is innate or inert, so it isn't oxygen rich. We can do that there to gain whatever we want to, and even if it is oxygen rich, then we can do that there to actually burn out the resources, turn them into other types of particulates so that we can just harvest them straight out of the planet. I know that sounds even more insane, but yeah, that's another method to all of the craziness. So yeah, we would end up doing things like that just for the start, and we'd have these crazy large programs on other planets basically. 16 people is crazy large, just by the way, for starter's sake, because of the number of possible failures you're looking at. Possible failures grow just exponentially when it comes to human involvement in these space missions, and it may seem like that's counterproductive, but it's actually the reality of the situation. So the first thing that would happen on a foreign planet, like say for example Mars, if we went there, now there is a carbon dioxide rich, no, it's not a carbon dioxide, it's not a greenhouse rich environment. It is a pressure depleted environment with the gravitational reduction effect to make it even worse. So to sort out that planet, there'd be a whole lot more that would need to be done. First of all, you'd have to generate some kind of electrostatic or electromagnetic field to stabilize the planet, which is not simple, even though I'm making it sound simple with the way I'm saying the words. But yeah, there is another level of insanity just to say it casually. Whew. And on top of that, let's see, electrostatic interference to stabilize the environment. Then we'd have to build, it's just way too much to just even imagine the procedure. Some of you may have some idea what I'm trying to talk about, but it's not so easy to explain it. Let's see, what would be the easiest thing to explain? Yeah, okay, so think of Mars as being Mars being a ball of water, right? If you want to move the ball of water from one place to the other, the first thing you have to do is get it into a container, because if you put it in your hands, it's going to be absorbed by your hands in part. It's also going to drip all over the place, and you're going to lose a lot of it. Some of it you might be able to consolidate, and that's going to be your uh, gains at the end of the day, but it's not really going to be that much. You're going to lose the vast majority of that water, regardless of what you try to do to keep it safe. So if you don't have a container, then you don't get anywhere. But the moment you make a container, now things start to become different. Even with using your hands, the amount that you could transport was very limited. But with the container, all of a sudden you can transport 100 times what you used to be able to transport effortlessly. Let's see, what did I unlock so far? Flower spreader. Next is gas extractor. Algae grower. That's fantastic. I can get to that. Heater T4. That's quite big. This is what I've been waiting for. Yep. Fertilizer. That's just the level 1. You can upgrade it later to level 2, and that starts up a whole lot of stuff. Oh, this is just well timed. Oh yeah, so like I was saying about actually building this, so I was already at the part where we'd use an electrode type situation to actually harvest any chemicals that we require. So we'd be extracting our metals either by directly liquefying them and turning them into raw metals. Then we'll have a massive amalgamation of liquid metals that we can electrify to keep apart, and just by maintaining a temperature we might be able to actually split it into various factors that make up the particular object that we're after, and that's how we would actually get to another stage altogether. I just realized that I didn't have a mushroom grow. These are just regular materials. For a second there I thought I saw purple. That's when you get pulsar quartz coming down. I did interfere with the way that the atmosphere was being built up just by putting that algae generator. Algae will produce carbon dioxide. It's going to change the heat and pressure characteristics. That's what they basically want you to see here. But obviously that there is on a much larger scale that you'd require to actually do it for it to have any effect. I don't know if this will sink down to the bottom, but I know that it should rise. And when you first start creating things to terraform a planet, it's actually the easiest point for it to fail. Even if you get into any point of lower points towards a balanced starter, provided you haven't reached balance, your life won't actually survive. It's kind of complicated to explain it properly, and I know I'm making a mess of the way I'm saying things. It's just so hard to explain them. I don't make a flower spreader while I'm at it right now. Okay, so how would I explain that section of building a planet? It's quite literally building a planet at that point. There's nothing else to it. I want one of the heaviest plants I can get my hands on. And by heaviest I mean you get heavy multipliers. There's 400. $600 golden, yeah, that's the max. Okay, right. So basically, as I said, you're gonna need to harvest your resources. So the first way you can get it out is in the form of liquids. So you liquefy all your metals through electrolysis, and you'll end up with these massive puddles of amalgams. That's because they are a mix of variant metals, and you can take that and mix it with other chemicals and extract them, or you can do differential heat separation of that amalgam. So you heat the whole thing up and then you slowly spin it out in a centrifuge of a sort, and you slowly bring down the temperature, and by dropping it by 10 degrees at the very least, anything that doesn't have the 10-degree borderline for keeping itself liquid will end up spreading itself to the outer edge, and you'll end up with a separation in your amalgam. You'll get some pure metal and some mixed filthy metal in there, and you can then clean it up much easier with the chemical. And you can keep doing that over and over again, and you'll have all your metals separated. Then your pure metals, your amalgams, you separate them out. Your amalgams, you chemically treat them, you remove them from each other, you reverse the chemical processes. You might even end up at electrolysis for a second time in your step, and there you have it. You have everything that you need for your building blocks in terms of metals. Now that is just the baseline for everything here, and talking about this crazy chart over here, oxygen parts per million, this is just for us to be able to have a breathable atmosphere. Heat is heating it up, and you would not be using microkelvins, or yeah, this is micro. This is millipascals, which is ridiculously low. That's even lower than Earth's atmosphere, which is in PA, and that's just one up if I'm correct. So yeah, so the first thing you're going to be looking at is not any of these. You're going to be looking at pressure and parts per million in the atmosphere. You're going to start changing those two things. Your pressure is going to change immediately with certain things that you're going to do to the planet. So for example, we go to Mars, we want to increase its gravity, we want to increase the planet density. Because we don't have enough heat and temperature coming out from the planet, increasing its density will improve the temperature slightly, but improving density isn't as simple as, oh yeah, we're just going to take material and dump it on the planet. That's just going to increase its mass. Density has to be packed into the planet, which is where things get really iffy in terms of chemical and mechanical processes. We may have to use nuclear power plants on a planet to do what I'm about to say, but Basically, we create a massive drill pipeline and um, inject something like uh, like a sun's. This is like so hard to explain even in simple terms. Uh, you have to inject your material into that planet, regardless of what you want to do. It's the only way that it's going to work. You're going to be pushing so much of matter into a planet that it's just ridiculous to come out with simple figures to say how much you're going to be interfering. And that's just me trying to be a little bit less ambiguous, but I'm being totally ambiguous. And the reason why it's coming out ambiguous for me immediately, it's because it is that hard to actually calculate. You're talking about figures that go up into hundreds of thousands of kilograms, and you're talking about items that shouldn't be measured in the manner that I'm talking about measuring. Okay, we've got oxygen, we've got water. There is some uranium in that ship. I do know that I'll have some, so yeah, I'll go grab it now. So yeah, so that's just the starting aspect of terraforming a planet, and you're gonna try and change the inside of the planet with the particle accelerator. It's going to have to shoot down into a planet with tons of material per hour being transferred into the planet, and your accelerator is going to have to move so fast that you exceed the pressure of the inside of a planet, which is where it gets even more ridiculous from what I'm saying. And this is the reason why it's more ridiculous. If you're thinking about exceeding the pressure inside a planet, remember, planets have pressures that are in, let's say for example, the inside of our planet, it's tens of thousands of Pascal per centimeter, which works out into the gravitational scale where we end up with 10,000 Gs near the core of the planet, which is kind of ridiculous if you're thinking about it. You're going to have that type of acceleration, 10,000 meters per second on every single square inch of material that you deposit into the planet. So yeah, it's ridiculous in that sense. But that's just the start of all the craziness that you have to go through if you actually want to do the things that I'm talking about when it comes to terraforming planets at a time. So yeah, you do that thing into the planet, and you can't have anything interfere with your processing. Okay. This is just ridiculous. Just came in here and I took out pointless items. Okay. Yeah. So that will be your first process, and in terms of time it will take to complete it, I don't mean to sound like this is like impossible or anything like that when I'm saying this here, but you're talking about a figure of time that goes into tens of thousands of years at the minimum. Yeah, well, anyway. Okay, so once you reach that stage where you're developing your technology and you actually have a sustainable gravity which is properly calibrated to what you want, and you've changed your planet's density, you're generally going to end up with heating up of the core, and that's going to end up heating up your surface. So if your planet doesn't have enough hard materials and your core, not your core, sorry, not your mantle, your crust isn't thick enough, when you do this here, the heat is actually going to melt away your crust from underneath you. So you'd actually turn your entire planet molten if you are going for the crazy route that I just said. And the only way for you to get out of that would be for you to actually there isn't a way out of it actually, as far as I can understand, because there is no way to turn a molten surface back to its hard surface instantly. It's going to have to be the cooling of the planet, which will have to happen naturally over time. And because of the amount of pressure you'd have to put through the ground, there's no option but to put that much of energy into the ground. And generally that planet will be unbalanced and it will try to reach equilibrium quite quickly. It might expel all of its gases and you might lose your livable atmosphere on that planet almost instantly, which is another crazy thing to think of when you do things like this for experimentation purposes. Sorry about the silence, it's just that I'm thinking about some heavy stuff and how to actually put it into a calculation, a viable calculation, that is. So yeah, it's not quite simple as I make them sound out to be, but oof. Okay, so calm down, say everything properly instead of getting jumbled up and mixed up. Okay, yeah. So after you finish off with that primary stage, then the next stage is actually altering your atmosphere, because you obviously have to now start shifting it to your type of atmosphere that you want. So you're going to start with that whole changing gases into innate forms. If you have oxygen-rich environment, you have to start changing it into different types of gases. Remember that Earth's atmosphere is 75 or 79% innate in the form of nitrogen. Then it's 20% in variable gases, with oxygen making up less than 2%, and or is it less than 10%, carbon dioxide less than 2%, which is 12%, and everything else is variable gases all around us. That's all of your dioxides and all of the other waste products. They form 12% of what we breathe in every second, or 13%. So yeah, that's the possibility on it. If I'm correct, at 75. If I'm incorrect, then it's a little bit less and the toxins are a little bit lower. But that's what it takes to actually reconstruct the atmosphere. Now, the way this game makes it seem like you can do it from one area, that's partially true, but it will also start to break down with the Le Chatelier's principle of physics. So the moment you start to push that type of atmospheric change, the planet will try to reach equilibrium and push back on the conversion. So yeah, this episode will be a little bit bigger because I said I will explain everything here. So yeah, so if you do it in one place, the Chatelier's principle will kick in and it will start to balance out the atmosphere instantly. So even though you're creating, say for example, oxygen, carbon dioxide, and nitrogen to fill up the atmosphere in ridiculous figures in one place, the rest of the planet will either freeze out the nitrogen, which is a process where the nitrogen will turn back into its liquid form and seep into the ground near its poles or something of the sort, or you could end up with other effects to take up the nitrogen, like lightning turning it into nitrogen oxide because of the oxides that you're dumping into the atmosphere, and your own counteraction would actually become the counter to your own plans, making it kind of counterproductive. Why isn't this here melted? Yeah, I'm drifting off on this here. Sorry about that. So, yeah, so once you've reached that stage with the equilibriums and things with the Shatlia's principle, it becomes quite difficult. That's why you have to start spreading out your colonies. Remember, you have to start off with about 16 people. So your first colony, which can host 16 people, you're going to create the second colony, which can host 16 people on the exact opposite end of your planet. Now, the reason behind that is you're going to be less than 10 years into your process, so you shouldn't have children and you shouldn't be expanding as yet. Internally, you should have a completely livable biosphere within your first base. Your second base is going to be the exact same thing, and then you're going to start to spread out with regards to a sphere into 4 additional quadrants after that there. So remember, you're 16 people, you move on to the second place, you all set it up together, so that's 2. Then you'll split up, so on each place there's 8, and you'll then need to be split up into 2 teams of 2 to take on 2 different locations in exact opposite coordinates of each other, giving you 6 locations on the planet where you are putting out all of these mass emissions. Obviously, it's going to be slower in terms of setup, but the amount of gear and equipment you have should actually make it faster for you to do it at that stage. It's kind of a complex equation when you think about it, but the further you are on your scale of development, the faster it is for you to actually get anywhere. Oh, I need another eggplant. I didn't realize that. Yeah, so that's what you're going to require to do just to get your planet kicking up. And remember, you've already harvested materials with the rudimentary way through electrolysis, and you started to do filtration. Then you can start regular mining like what we do on Earth, where you blast and you take out sand, then you crush it into small powders and you extract in that manner. Because remember, now your atmosphere is changing, you have the higher gravity, you have everything to your particular liking, and you can still use electrolysis because it's still far faster than the other forms of melting, and you can also separate a lot of things in the exact same way. So basically that was everything that there is to starting off the terraformation. The next processes are where things are just uncontrollable. Once your atmosphere starts to start balancing out with what you've been pushing into it, you're actually going to overshoot your mark slightly, and then it's going to start to reach an equilibrium. And that's going to be the natural equilibrium that your planet will have. And you're going to start slowly shutting down your production, and it will start to ramp down till the atmosphere becomes stable in a sense that you want it to be. At this stage, that's where you go out and you start spreading algae, where you start spreading seeds for trees and grass and things like that. They're all at once. You're going to spread bacteria, you're going to spread insects, a whole load of things will actually have to be spread on the ground to start this off. And you actually aren't going to be doing it in single form. You're going to be spreading hundreds of thousands of different bacteria, hundreds of thousands of different insects all at once, all across the planet. And then after a while, everything will start to form their own ecosystems. They're going to go partially extinct, and they're going to start to adapt to their new environments. And some of your trees will die, some of your plants will die. This year is what takes that 100 to 200 years on most of terraformation of any planet. So yeah, by the time you're done with that first section, it'll be about 40 years where you actually start noticing that greenery is out on your planet, and it actually has a stable oxygen environment possibly. So you can actually now move around with simple breathing apparatus instead of complex breathing apparatus, and you can actually breathe in the atmosphere. Your temperatures may not be suitable for you to walk in, because you're still talking about a planet that's adjusting to these types of pressures. The greenhouse effect hasn't pulled it up to positive temperatures in the complete, so you're talking about low 5s to 6 degrees Celsius days and nights on the planet in the heated exchange, and negative 40 to negative 60 in the freezing temperatures on that planet. So your plants are going to have to get hardy, so they have to be able to adjust to this naturally. So those are the things that are going to happen. Your bugs and insects will find ways to survive. That's how come I said they will go through partial extinction events. So yeah, that's just about it for now for me. I'll get back to you guys another time when I have more to talk about, because there's so much more with regards to all of this, and that's just how you start up actually doing these things. Naturally these things will have to spread by spora dispersion, or by rapid exposure. So you have to blast out seeds in small little groupings each time. So you might have to do something like 100,000 times the amount of seeds that would be required to cover your planet. Obviously you can't take that with you. That's more than the weight of a rocket could ever handle. You'd actually start off with less than 2 handfuls worth of plants, and you're going to have to grow them. You're going to have to seed them, take their seeds, seed those seeds into fully grown plants, gather those seeds, which will take you something like 6 months to reach this point, and that process has to keep going over and over and over again. Then you make your first mini spore bombs. You're going to throw them out on the atmosphere. Remember, you've already created 6 livable zones on that planet. That's approximately 20 years into the planet. You now have children. That's why each one of you are in a different habitat across the planet. There's 6, and there's a total of 16 people. So 6 at 16, that means that there's not exactly 2 per each zone. There's an odd number of people in each zone. Some people transfer between zones periodically. Their whole duty is actually on the outside to look after the planet itself, to see how things are developing, and to find more mineral sites and things like that there. So that's the whole reason why you'll swap so often. And then eventually, when you'll reach the 30th and 40th year mark, that's when everybody gathers together in a single biome, where you'll have your first generation of children just exiting puberty. So they're now just reaching that end stage where they're 16 to 20 years old, and you expose them to other people from the other colonies, and that's how you continue with your reproduction on those planets. So yeah, that's how crazy it is to do terraformation. And remember that there is 40 years after your start. So basically your inhabitants who start on that planet have to be 20 years old to be able to follow that program. Otherwise, anybody who's older than that most probably will die before that period is over. If you started off at 30, 40 years later, you're 70, that's past the average human lifespan. So you have more than an average chance of not surviving. Plus, those are harsher environments and so forth. So yeah, that's everything that you need to know about actually planet crafting like this year. So catch you all in the next one. Have a good day.